So let us quickly recall what did we see in last lecture. Can anyone tell? Let us quickly recall. Till this point in time, we discussed about, we have started with AI. Okay, we discussed about all the topics of artificial intelligence, including machine learning. And in machine learning, we talk about all 4 types of learning. Which are the 4 types of learning? How do we make machine learn capable exactly like a human? There are 4 types of learning. Which are that?
Sir,
Super
supervised, unsupervised reinforcement.
and semi-supervised.
Semi-supervised, right? So when you put together all, it will make a whole subject of machine learning. So we want to mimic a human brain inside computer. We want to make machine learn exactly like a human. And for that reason, we are studying this whole subject. So this is the overall evolution. You can see that first, all concepts which are related to AI were coined. Then machine learning comes in the picture, and then in after 2008, the biggest breakthrough happens through GPU and that special workstation and big computation and everything is made available. After that, people have started talking about deep learning. Okay, so it is a self-learning from huge amount of data, or if you learn based on deep neural network architecture. So that is again a sub branch of machine learning. So there are certain observed disadvantages, shortcomings of machine learning, and then we should move to the deep learning, right? But again, we should not misuse the technology like deep learning. If you can achieve better efficiency, accuracy with good precision with machine learning algorithms, either with supervised or classification, unsupervised or clustering, association, dimensionality reduction, semi-supervised or reinforcement learning, there is no need to jump into deep learning. But if you have a computer vision kind of application, audio, video, like multimedia applications, images, and if your machine learning algorithm takes too much time, that is efficiency is always compromised, then in that case, we should go for deep learning, right? But when we go to any deep neural network architecture, there are certain requirement, right? The first requirement is huge amount of data, means terabyte, petabyte, yottabyte amount of data you require. You cannot work with MBs and GBs of data, because you have to train the model and model will learn itself from the data without doing a lot of coding. So as you are moving from AI to ML to DL, coding will be lesser, but data requirement will be higher. So here we need to pass huge amount of data. Second, you require special workstation with GPU, or you require good computation. Okay, so any kind of high-end servers you require, and you require more parallel cores, multiple cores. So that is where second requirement is there. And third is you have to design efficient algorithm. You see, deep learning is never guaranteeing that by using deep neural network architecture without having proper tuning of parameters and hyperparameters, without efficiently designing the algorithm, you can get a better results. So it is up to you that you have to design efficient algorithm, you have to tune parameters and hyperparameters, optimize that value so that you can get good accuracy with good efficiency. So this is what is the fundamental difference between neural network and deep neural network. You can see that in neural network, we have a few hidden layers. But when we talk about deep neural network architecture, we have a stack of hidden layer, hierarchy of hidden layers, right? So here you can see there is a complex structure, a lot of connections, and there is a thorough training which is going to happen. And based on that, you can always imagine that the results which are being produced by deep neural network architecture is of course going to be the better than the your conventional or simple neural network. But obviously time requirement will be higher, and that's why we should work with GPUs and we require more parallel cores or concurrent cores, right? Because you see there is a complex calculation, so many connections, and if all this is to happen concurrently, then and then you will get better accurate results, better precise result in a quick time. And the reason why we require GPU, due to a lot of complexity here you can see. So this is the general architecture of neural network. You can see that here in a conventional or simple neural network, this is the input layer, this is output layer, and this is a hidden layer. This is exactly how our human brain actually works. So what we see is the input, what we classify, recognize, predict as the output, and what happens inside our human brain, no one can see. That's why it is hidden. So actual processing always happens inside the brain, and that's why this is a hidden from outside the world, and that's why it is called hidden layer. Right. So there are no connection between neurons in a same layer. So we have so many biological neurons in our human brain. So here we created artificial neuron, and you see that each and every neuron is connected with each and every neuron in a adjacent layer. And this is how they are connected with the output layer. But here, if you see, there's a stack of layers, and the things will become complicated. A lot of computation is there. So here, multiple processing layers are there, and hierarchy of layers. You can see stack of layers. It is composed in the architecture, so that you have a this kind of network learn complex representation like images, sound, audio, video, text easily in comparison with your conventional neural network. So this is what is the difference between your conventional neural network and a convolution neural network or a deep neural network. So always input and output layer is always one. You can have more hidden layers, right? So here we have a 15, 20, 30 hidden layers as per the requirement. And as you can see, there are a lot of computations, lot of connections. Thorough training is going to happen, deep training is going to happen, and the reason why it's a deep learning. So here your learning is going to be deeper than what you can see with a conventional or a simple neural network, and that's why it is called deep neural network, or you can consider this as a deep learning. So this is what is a fundamental difference between machine learning and deep learning. In machine learning, feature extraction has to be done manually, right? And then I have to construct the feature vector. So like if there is a car, then I have to extract the feature of car and I have to hand code it. And then this is to be supplied to the classification algorithm. So my automation will start from here. Up to this point in time, it is manual, right? So up to this point in time here, you require the coding. So feature extraction has to be done manually. And then this whatever classification algorithm, that decision tree, neural network, support vector machine, random forest, whatever you have selected, it is to be supplied, and based on that it will be classified whether it is output as a car or not car. But if you work with a deep neural network architecture or deep learning, you can see that this is also going to be automated. So feature extraction plus classification. So no human intervention is required, right, from the huge amount of data, but here you require a lot of images in comparison with machine learning. So here we have to manually extract the features and construct the feature vector. Here it will be done automatically. So you require huge amount of data without doing any kind of coding. Feature extraction plus classification, both will be done automatically. It is automated, and based on that your output will be whether it is car or not car. Right. So please remember, this is what we have to achieve in terms of deep learning, right? So feature extraction plus classification is fully going to be automated, while here you have to extract your feature manually and then you have to supply that to the classification algorithm, so that then automation will start. So this is what is a fundamental difference between machine learning and deep learning. Right. So as I've said, there are three biggest requirements, whether it's a structured data or unstructured data. Like audio, video, image, whatever, you require huge amount of data. Second, you require GPU because you require here concurrent cores, as lot of complex calculations, lot of connections are there because hierarchy of layers are there, stack of layers are there. So you require GPU, special workstation, and of course it is up to you. You have to design efficient and accurate algorithm. Then and then you can realize the power of deep learning. So if you see the graph of X versus Y axis, amount of data as it is increases, the performance, of course, if you want better performance, then you require, you see, for lots of data, you require appropriate hardware and appropriate computation with GPU and all, and then you have to design optimized algorithm. Then and then you can deal with large neural network, right? So as you are going for large neural network, you can have so many hidden layers, lot of computation, lot of connections. And the reason why you need to design optimized algorithm, you require specialized workstation with GPU, that is hardware, and you require huge amount of data, means terabyte, petabyte, yottabyte amount of data, because here it will learn from data itself without doing lot of coding. So learning from huge amount of data without doing any kind of coding is nothing but a deep learning. So please remember, this is possible after 2008, because after that GPUs and other TPUs and all processors have been invented, and a lot of codes are available so that you can concurrently deal with huge amount of data, huge number of connections. And now any kind of unstructured data you can deal, including all multimedia data, that is audio, video, image, sound, etc. Right. So these all are the applications in a computer vision. So your number plate identification in a vehicle, right? In every toll tax, you are aware. This is what we are doing with that. Facial recognition, mood recognition, person recognition, right? You can do it. Information retrieval, like all the search engine, including whatever Google or Yahoo, what you use. So whether it's a text search or image search is an application of this deep learning. Any kind of marketing, whatever automated email what you get, or the videos which are being recommended to you is an example of this deep learning. Medical diagnosis like cancer identification, anomaly detection, these all are the applications of that. NLP like sentiment analysis, tagging someone on inside the photo, this all are the applications of deep learning. So these all are the various kind of models which are available, or various kind of architectures. They are called deep neural network architectures which are available. Okay, so convolution neural network, recurrent neural network, deep belief network, recursive neural tensor network, RNTN, long and short-term memory, LSTM, restricted Boltzmann machine, autoencoder transfer learning, and generative adversarial network, GAN. And now the latest thing which has been added is a self-supervised learning. Okay, because the things are changing very fast. Unless and until we become adaptive, it is very difficult to survive. So all of we have to update and upgrade all the time. So you can see that GAN has been invented before 1 or 2 years, and now self-supervised learning, which is a new concept which is to be added now after this inside this PPT. So these all are the various types of deep neural network architectures, right? And these all are the various kind of deep network neural networks. And obvious question is for which kind of application which is to be used, right? So same issues we faced during machine learning also. Means when we talk about 4 types of learning, then like classification, then which classification algorithm to be used. Same way for clustering, which clustering algorithm is to be used, and same way here. So if you have a multimedia data or computer vision kind of application, right? So like then which deep neural network architecture is to be used out of all that. So please remember, this is what you should know if you are moving away from machine learning and going towards the deep learning. So this is what is an answer. Like if you have a text processing application, like text analytics or NLP kind of application, you can use RNN and RNTN. RNN is recurrent neural network, and RNTN is recursive neural tensor network. If you have image recognition, then CNN and DBN, convolution neural network and deep belief network. If you have object recognition from image, right, you have to recognize the object, then CNN and RNTN, convolution neural network, and RNTN, that is recursive neural tensor network. If you have speech recognition, then RNN. If you have speech recognition, like who is speaking, based on that you have to recognize the speech, RNN. Then time series analysis is RNN, recurrent neural network. And if you have unlabeled data like clustering kind of application or pattern recognition, then it's a restricted Boltzmann machine. That is your RBM. Right, so this is what you should remember, like for which kind of application, which deep neural network architecture can be used. This is the comparison of various deep learning models. Okay, so in column, all these models are there, and in a row, we have a various characteristic. So like type, what is the purpose, for which thing they are suitable for, and example for each category. So here you can see that CNN, RNN and LSTM, they are used for describing the concept. So it is called discriminative. The type is discriminative, while RBM, restricted Boltzmann machine, deep belief network, DBN and autoencoder, they are used for generative purpose. The type is that. And then purpose, here you can see CNN is used for classification, RNN, LSTM for prediction, RBM for unsupervised feature learning, DBN also for unsupervised feature learning, and autoencoder can be used for dimensionality reduction. So those attributes which are irrelevant, if you want to remove, then you can use autoencoder. Then suitable for processing two-dimensional data, you can use CNN. Sequential data, time series data, then you can go for RNN. If you have a long sequence of data, then you can combine RNN with LSTM. If you have a learning distribution of data, if you have distributed data and how the data is distributed, then you can use RBM. Creating a probabilistic recommendation of data, then you can go for DBN. And if you create a compact, you want to create a compact representation by excluding those features which are irrelevant, then you can go for autoencoder. So for computer vision, image and video kind of application, you can go for CNN. Language models and speech like text analytics, NLP and all, you should go for RNN. Same way for LSTM, right? So here RNN is not having memory. So if you require memory for long sequence of this sequential data, then you should go for LSTM, RNN with LSTM. For RBM, here it will generate the samples from learned hidden representation, and DBN, trained layer used as feature detector, and on autoencoder like principal component analysis, like which are the major attributes, dimension, features which can be used for the purpose of your classification or prediction. Fine. So why we should go for deep neural network or deep presentations or representations, right? So your deep neural network always makes relations with data from simpler to complex, right? So it is going from simple towards the complex in a step-by-step way. So here it follows layer by layer approach. In each layer, it tries to make a relations between the previous layer. So for example, if you have to recognize the face, then it will start with the edges. You see that from image, it will detect the edges, then face parts, then the faces, and then the specific desired face. Same way, if you have an audio recognition application, so from audio, it will first detect the low level sound features, then phonemes, then words, and then sentences. Okay, so layer by layer, it will work. And it is exactly like our working like a human brain. So we always try to think from simple to complex. Right, so deep neural networks always thinks like brain, and it always try to work from simple to complex. So try to see that if I have to recognize this kind of pattern, which is being shown here, then in a first stage or first layer, you can see that individual lines, then it will combine these lines. Then in a third stage or third layer, it will again combine, and then it will detect this. So it's a layer by layer or stage by stage. This is what they are saying, right? So in each layer, it tries to make a relationship between previous layer, and it is moving from simple to complex. Same way here, you can have a face recognition, right? So here, you can see that in the first layer, the computer identifies pixels, that is which one is light, which one is dark. In second layer, computer learns to identify edges, okay, and the simple shapes. In third, computer learns to identify more complex shapes and the objects. And in four, the computer learns which shapes and objects can be used to define the human face. right? So this is what is my deep learning architecture for convolution neural network. So see that this is how it is actually working. Like I want to detect this kind of object, try to see that. So this is my convolution plus ReLU. Then I have a pooling layer, then again convolution plus ReLU, then pooling, and then afterwards there is a fully connected network. So your actual classifications are going to start from here. But here it will detect the objects, right? So feature extractions are to be done from initial layers. So this convolution plus ReLU and pooling, this is always used for detecting the various objects, and after that there is a fully connected network to which it is being supplied, and based on that it will identify the various object or recognize like dog, cat, boat or bird. It will classify. So the actual classification is going to happen through this fully connected network, but prior to that you have to identify these individual objects in a layer by layered approach, right? So this is how it is actually working. So let us now discuss the various application. Try to see that if I just classify cat, okay, and if I separate it from dog, then it is called classification. If I classify and now I am putting a rectangle, so it is called classification plus localization. So both these are I have done on a single object, okay. So here you can see that I am working on a single object. So this is called classification. I am classifying cat from a dog or whatever object. Then I am localizing also. So localizing means what? I am just detecting only this object. So I am putting rectangle on this specific object. It is called classification plus localization. Object detection. So cat, dog, and duck. Okay. So you can see that this is I am duck, this is dog, and this is cat. So there are three different colors of rectangle which is going to detect these. So cat is for red. You can see that red rectangle. This is blue is for dog, and duck I am using green. So here it is for multiple objects, because here more than one objects are there. So it is called object detection, but here I am working on a multiple object. This is called instance segmentation. Okay, so now I am just segmenting all the instances. So 2 cat, 1 dog, and 1 duck. I am instancing all these are the instances. So I am doing only segmentation. So you can see that the boundary is being specified. So it is called instance segmentation. So this is on a single object. This is on multiple object. It is called object detection. This is classification, classification plus localization, or it is called instance segmentation. This is also an example of object detection. Try to see that. So here I can put a label along with the rectangle: person, horse, dog, car, right? Another person, bus, driver, or a person. See that inside that boat, person, 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 again inside person, cat, dog. So try to see various types of images. Okay. So here inside bus there is a person. So inside image there is an image or an object. Here you have multiple objects on a one specific board. Here two different kind of objects. See that, and here various objects are there. Like so, these all are the example of object detection. All right, so this is my mood recognition. You can see that. So you can see the facial expression, and you can see it is a surprise. This is surprising. Okay, so here are like happy, surprise, sad, neutral. This is activity recognition. Okay. So here like fencing, okay, field hockey penalty, you can see that. So they are doing penalty corner here, and hula hoop or dancing, right? So what activities you are right now doing, like which operation you are executing right now, which activity you are performing. Activity means what? Operation in execution invocation, that is called activity. So from video, you can recognize this kind of activity and you can put a label. This is called activity recognition. This is my semantic segmentation, right? So here you can see that there is a sky. So this is my tree. So tree, then you have fence, sidewalk, okay, road. This is again fence, so you can see fence, street light. So this is my street light. Then you have a signboard, so sign. Here there is a car, so you can see there is a car. Right, so this is a semantic segmentation. Try to see in the various kind of images, you have a various segmentation based on similarity. So it's a semantic segmentation, meaning wise segmentation. So if this is my input image, this is what is my output of semantic segmentation. So these all are the applications of your deep neural network architecture or deep learning. All right, then you have a pneumonia detection. So you can see that if you have 4 different radiologists who is seeing your image, like X-ray image, and based on that they are detecting the score. Okay, so this is a F1 score which is being given by radiologist 1, 2, 3, 4, and their average score. And I have a application chessex.net. Okay, so you can see that it will give you much more precise result than the average score which are being given by 4 radiologists. So if I can supply this X-ray and my deep neural network architecture, it will find out whether the person is suffering from pneumonia or not. You can see the accuracy based on that. So this is an automation. Okay, so this chessex net, this is the automation of pneumonia detection. Same way, we have a chest X-ray. Okay, so I have a various radiographs, and my deep neural network architecture, it will classify them like by seeing which are healthy, which are suffering from pneumonia, and which are suffering from COVID-19. So it is basically a classification. So it will take one by one all the images, and it will classify whether the image is healthy or suffering from pneumonia or suffering from COVID-19. Image colorization. Try to see, this is a black and white image, and this is one type of colorization, another type of colorization. Okay, so this is by using one method, and this is the ground truth. So you can see that it's almost same. So this is also input. This is by using some of the method which people have implemented, and this is the ground truth. So image colorization, right? Movie colorization, all of you are aware, like Pakizai and all other movies have been converted from black and white to color. This is also an application of deep neural network or deep learning. Photorealistic style transfer. So if I'm combining first and second image, and you see that both this will be converted into this new image style. So it's a style transfer, photorealistic style transfer. Same way, this and this is original, this is reference, and this is result. So if you combine these two, so it is my photorealistic style transfer. Drone control, right? You are aware drone is used everywhere now. So this drone can automatically follow the forest trails to track down the lost hikers. Okay, and this is inside that, like you see, there is a deep neural network architecture, and it will pass on the control signals, and accordingly it will be guided. Then this Virgo robot is designed to pick the tomatoes from the plant. Okay, so see that again, this is an application of deep learning. Then automatic localization and count of agricultural crop pesticides. Right, so here you can see input image, and we have a desired output from the image. So you can see that where you have to drop the pesticides on a plant. Okay, so you can see that there are certain diseases. So it will identify, and now you can easily see that on this part you have to actually spread the pesticides. So this is classification and localization, right? Then we have a self-driving car or driverless car, right? So again, this is an application of deep learning. So self-driving car, this is also an application of deep learning. Then sensory meter deep learning. So in this project, we aim to develop deep learning techniques that can be deployed on a robot, right? So that we can allow it to learn directly from trial and error, where the only information provided by the instructor is the degree to which it is succeeding at the current task. Okay, so at what degree it has to rotate it and how this has to pick up the object, right? So this is also an application of deep learning. In a game playing, right? So yes, it is largely used in a game playing. So here the bot learned the game from the scratch by self-play. It does not use imitation learning or tree search. So here it will accomplish well-defined goals in a messy, complicated situation involving real humans. So this is for your recurrent neural network, right? So here there is a feedback or loop back. You can see that here you have to learn the sequence data, means the previous state always you have to remember. So this is the architecture of recurrent neural network. So these are the applications of recurrent network. Automatically adding sound to silent movies and automatic text generation, right? So like man is in a black shirt is playing the guitar. So if I give this image, you have to do automatic text generation based on this, like this. Here you can generate a text like construction worker in orange safety vest is working on a road. And here two young girls are playing with a Lego toy, like this. So these all are the applications of RNN. So these all are the variety of tasks which you can perform with a text processing or NLP, natural language processing kind of application, or text analytics kind of, you can perform classification, fact extraction. Okay, you can extract the people and company name, geography, prices, dates, product names. You can model the languages, language modeling, part of the speech recognition, key phrase extraction, finding synonym, machine translation. You can search written and spoken words, question answering, dialogue systems. Entity extraction. Okay, so from a text, you can extract various kind of entities. So key phrase, language, sentiment. Okay, this all you can extract. So entity extraction is also an application. Live translation. Okay, so you can translate from one language to another. Then this is Google Translate. Okay, so from one language to another language, you can easily translate. And you are already aware about Alexa, Google, right? And Cortana voice search. Even in your email, short text messages which are automatically generated for the reply is also an application of deep neural network or deep learning. Document analyzer or classifier. So it will take one by one document and it will classify them into various categories, like which are the documents of type technology, sports, entertainment, education, like all that. So document analyzer and classification. Then text generation, then Google Smart Reply, as I already said. So whatever in your email, the smart reply which are being generated automatically, and you can straight away use it without typing. So this text generation or Google Smart Reply is also an example of our deep learning. Review generation. Okay, so like the way humans generate the review and assign the grade, we can automate this process of review and it will assign the grade like a human. So you see all these are machine generated reviews. Okay, so 3-star, 1-star, 5-star like that. So yes, you can automate the process of review generation exactly like a human. Question answering, right? So you can also automate this process of question answering. And you can see almost 82% accuracies have already been achieved in terms of question answering with a full automation. So this is my paragraph input and this all questions you are asking, and you can see that it replies from this automatically. So it is going to be trained on this text, and then it will answer the question which are being raised from this particular text. So yes, question answering. Chatbot, all the chatbot applications are part of your machine learning and deep learning. So first you have to train on your frequently asked questions, your chatbot. And then when you make a phone call, you will receive the answer from a machine, and the human think like they are interacting with a human. But ultimately the answer is coming from a machine. Right, so see that this answer is coming from a chatbot or a machine, and we can make a person fool or believe that they interact with a human, but actually it is a machine. The recommender system, like in YouTube and all your movie recommendation, whatever you see in Netflix, they all are part of your recommendation system. It's basically a prediction system. So based on your past search, it will recommend the future things. Right, so it is equally applicable in terms of your YouTube. As per your likings and as per your past search, it will recommend certain kind of new videos. So yes, recommendation system is also a part of your machine learning and deep learning. And this all organization they use, like Facebook, they use the recommendation, like people you may know, they try to recommend. Netflix, right? Other movies you may enjoy, similar what you have seen in the past. LinkedIn, jobs you may be interested in. So based on your job profile, based on your background, it will recommend you certain kind of new jobs. Amazon, customer who bought items like based on their hobby, income, profession, and past bought. Google, visually similar images, and YouTube, these always recommend the videos, right? So these all are currently uses this as a recommender system, and these all are the applications of machine learning and deep learning. Sentiment analysis, right? So you want to see the emotions of the people, okay? So whether it is steady or whether it is going in a positive way or negative or neutral. So sentiment analysis, right? So whether you are satisfied, not satisfied. So yes, sentiment analysis to track your emotions. Now you can also learn in a multimodal way. That is, you can learn from text and image combined together. It is called multimodal. Okay, so yes, we can use it for text plus image combined. So multimodal learning, so image caption generation, that is image plus text, search web by an image, that is nothing but your image plus text. If you describe the video, right, then it is also multimodal. Visual question answering, that is image plus text. Speech recognition is audio plus video, that is the lip motion, you can check. Image classification and navigation, that is your color plus depth. So this all are the application of multimodal learning. They are also part of deep learning. Right, so here you can see there is a caption generation, text by an image. So this image I have to generate a text. So you see there is a deep convolution neural network followed by RNN, which is used to generate the language. So here, what is the caption? What you are going to generate? A group of people shopping at an outdoor market, and there are many vegetables at the fruit stand. Right. So this is what the caption what you have generated. So text by an image. So from image you have generated a text. So you see that CNN followed by RNN, which can be used for this image followed by the text. A group of people riding bikes down a street, right? So you can see that. Then video description, text by video. Okay, so someone sits on his bed. His head is on bed, and his eyes open, and he talks. He takes his hand. So this is how you can describe the video. So as the video progresses, such kind of captions need to be generated. So it is text by video. Okay, so you can just add the text and you can have a caption generation as the video is progressing. Image generation by text. Okay, so now you give the text and based on that image is generated. Like, so this bird is red with white and has a very short beak. And this bird has a green crown, black primaries and a white belly. So this is text to image generation. And generative adversarial network can be used for that. So image generation by text. Code generation by image. So you can generate the code from image. So this is my image. I used UI screenshot and this is the automatically generated the code. So now you see that no humans are required, no code is required to be written. It will automatically generate the code from this GUI screenshot. So code generation from an image. Yes, you can automatically generate the code if you supply. This is called reverse engineering. Right, and idea to HTML. So this is what is your concept you lay down on the paper. Okay, so this template is converted into actual HTML code in terms of static page. Speech recognition, lip reading, right? So yes, you can recognize the speech. You have to read the lip. Then generative adversarial networks, so GAN, as we have discussed. So see that here there is a generator and there is a discriminator. Generator will generate the images and there is a training set, and if you have not sufficient images, it will generate some additional images for you, and this discriminator is going to identify whether it's a real image or a fake image, right? So here generator will generate the fake images, these are the real images, and this discriminator is always going to differentiate between real and fake. So this is GAN, generative adversarial networks. Background removal, try to see from this image, we have removed the background and only the front image is there. Then object removal, you can see that this particular port has been removed. Okay, so this has been removed and now you can see without this the image is there. So object removal from the image. Image completion, like these are the incomplete images and you can see that you have added the remaining missing component and you have made it complete. So this is complete, this is complete, this is complete. So even if you have an incomplete image, you can have a complete image. So it is called image completion. Okay, learning lip synchronization from audio. So this is speech recognition. Generating images by generative adversarial network, and this is how GAN rapid evolution. So you can see that progressive growing of generative adversarial networks for improving quality, stability, and variation of various images. Multi-domain image-to-image translation. So this is my input, right? If you want to see on blonde hair, gender-wise, aged, right? What is the impact of age? Pale screen, okay? Same way you can have input angry, happy, and fearful. How you will look like. So multi-domain image-to-image translation. Okay, this is my winter image, and same I am converting that into summer image, sunny image, and I am converting that into rainy image. Right, so Sophia, this is again you are already familiar. This is also an application of deep learning. Self-driving car. Okay, so you have a lot of sensors, actuators, you see antennas. A lot of cameras, of course. Deep learning on genomics regulatory. Yes, you can use it for genomics purpose also. Ghazi attack. Right, so see this. Sonar data classification. So this Naval mine is a self-contained explosive device placed in a water to damage or destroy the surface ship or submarine. So our goal is to build a model that can predict whether the object is a naval mine or a rock. Okay. So in sonar data classification, so this all are the various applications, right? And this all are the challenges. So those who really want to work and publish the paper, those who want to pursue their master, you can see that scale variation in a single image. If there is a scale variation is there, still you will find a lot of difficulty in detecting such kind of objects. Illumination conditions, viewpoint variation, you see this, deformation, background clutter, it is your background and object both are same. Intra-class variation, you see there is a lot of various kind of chair. Occlusion detection. So these all are the challenges in your computer vision. If you can achieve with deep learning, your papers will be accepted, and if you develop such kind of project, it will be accepted also, and you will get good recognition. So these all are the practical challenges in computer vision right now, which are yet to be addressed. So those who are interested, they can start working on that. And these all are the Python libraries, right? For machine learning, you have to use TensorFlow, scikit-learn, PyTorch, Keras. For visualization, Matplotlib, right? Plotly, Seaborn, PyDot. For mathematics, SciPy, NumPy. For data manipulation and analysis, Panda and ScryPy. So these all are the various libraries which you can use in Python for performing the various machine learning tasks. So these all are the deep learning libraries, and of course cloud services are also available, provided by Amazon, Microsoft Azure, Google, okay, and Floyd. So you can use PyTorch, TensorFlow, Keras, MXNet, Caffe, Theano, Deep Learning 4J, YOLO, Chainer, CNTK, which are given by Microsoft, OpenCV, and you can use scikit-learn also. So these all are popular deep learning libraries, right, which you can use. And this is the comparison of various deep learning libraries, and try to see that these all libraries have been written in C++ or C language, right? So you cannot underestimate C and C++ language. So who has created, like TensorFlow is created by the Google Brain team. Keras is created by this Francois. Deep Learning 4J is created by Adam Gibson. Okay, so the under which license software it is available, whether they are open source. So most of them are open source. For which platform it is available. So now you see the compatibility between Linux, Mac, and Windows all are available. In which language it is written and for which languages it will provide the interface. So for Python, you can see for almost all Java, Scala, MATLAB. Okay. So interfaces are available for which other language, and CUDA support is there, means multiple GPUs are supported or not. So that is also there. And this is GPUs make deep learning accessible. So deep learning with high performance computing system, right? So you can see that Google Data Center and Stanford AI Lab. And we have also our AI Center of Excellence. DTX server is already with us. These all are the challenges. Here we have to deal with a huge amount of data. You have to avoid the overfitting problem, hyperparameter tuning and optimization, high performance hardware you require, and rapid and optimized development you require. Right, so these all are the conferences and journals. These all are the reading materials. So if you have any question. So I hope I have made it clear where deep learning is used in today's world, which are the real world application, use cases, utilities.
Yes.
So those who want to pursue master, those who want to build their career in the field of machine learning, deep learning, AI, of course, they have to develop good project. You have to strengthen your resume also. You have to strengthen your reference letter also, because you are going to take reference letter from your teachers. And in this recommendation letter or reference letter, you should have done so many of project. You should have published some good paper along with the teachers. Then you will get good standing. You can differentiate yourself from the crowd. You will get good relaxation in terms of fees. You will get good scholarship. You can get admission in good universities, and you can become a part of capacity building team in good companies, right? So Wipro, TCS, Infosys, Tech Mahindra. If you have a knowledge on other than technology on which they are working, like machine learning, blockchain, IoT, cloud computing, data science, then you can be a part of capacity building team. And of course, your evolution, your salary is going to be different than the others. Fine. So utilize your time fully. You are getting good time right now. Those who are not commuting, and you can save a lot of time. So please invest your time wisely and make your future bright. Watch a lot of small YouTube videos, enroll for good online course on machine learning, deep learning. Do a lot of practice, work with Python, MATLAB, Scala, Java, whatever platform in which you are comfortable, but realize all concept practically, right? And whenever you are in doubt, you can consult us. Okay, so if you have any question, otherwise I'll stop. I am ready to answer. So without machine learning and deep learning, no one can survive. Wherever you want to automate the things, whenever you want to make decision making exactly like a human, inside computer, you require this subject. So for structured data, right, for unstructured data, largely you have to go for deep neural network architectures, what we have discussed today. So start acquiring good domain knowledge in depth about all this CNN, RNN, LSTM, GAN, self-supervised learning, which has newly emerged. Okay then, thank you. Shall I stop?
Yes.
Yes, sir.
Yes, sir.
Fine. Okay, so start reading and start watching good videos, right, about the subject.